Hello and welcome back at the FinetLink channel. Now we are entering in the new module, which is Ethernet channel. For the moment, we learned that our network design includes redundant switches and links. So, as you know, we learned some version of spanning tree protocol configured to prevent layer 2 loops. But right now, like most network administrators, you will realize that you could use more bandwidth and redundancy in your network. So for this, you will need the Ether channel. Ether channel aggregates links between devices into bundles. These bundles include redundant links. Spanning tree protocol may block one of those links, but it will not block all of them. With Ether channel, your network can have redundancy, loop prevention, and increased bandwidth. And we will learn two protocols about the Ether channel. And those protocols will be port aggregation protocols and a link aggregation control protocol. And here we will explain them. We will learn how to configure, verify, and troubleshoot them. So based on this, we will describe Ether channel topology. We will configure the Ether channel, and then last, what we will do is about troubleshooting Ether channel. So based on this, let's go and see each topic. There are different scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. Multiple links could be connected between devices to increase bandwidth. However, spanning tree protocol, which is enabled on layer 2 devices like Cisco switches by default, will block redundant links to prevent switching loops, as it is shown here in this figure. A link aggregation technology is needed that allows redundant links between devices that will not be blocked by spanning tree protocol. And this technology is known as EtherChannel. EtherChannel is a link aggregation technology that groups multiple physical Ethernet links together into one single logical link. It is used to provide fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. Ether channel technology makes it possible to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication. And the Ether technology was originally developed by Cisco as a LAN switch-to-switch technique of grouping several fast Ethernet or gigabit Ethernet ports into one logical channel. When an Ether channel is configured, the resulting virtual interface is called a port channel. And these physical interfaces are bundled together into a port channel interface, as it is shown here in this figure. And what are the advantages of using the Ether channel? May have many advantages, which is included as most configuration tasks can be done on Ether channel interface instead of on each individual port, ensuring configuration consistency through the link. Ether channel relies on existing switch ports, which means that there is no need to upgrade the links to a faster and more expansive connection to have more bandwidth. Load balancing takes place between links that are part of the same Ether channel, which means that depending on the hardware platform, one or more load balancing methods can be implemented. These methods include source MAC address and destination MAC address load balancing. or source IP and destination IP load balancing across the physical links. EtherChannel creates an aggregation that is seen as one logical link, which means that when several Ethernet channel bundles exist between two switches, spanning tree protocol may block one of the bundles to prevent switching loops. And when spanning tree protocol blocks one of the redundant links, it blocks the entire Ether channel. This blocks all the ports belonging to Ether channel links. Where there is only one Ether channel link, all physical links in the Ether channel are active because spanning tree protocol sees one logical link. EtherChannel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. Therefore, a spanning tree recalculation is not required. Assuming at least one physical link is present, the Ether channel remains functional even its overall throughput decrease because of lost link within the Ether channel. But depending on the implementation of the Ether channel, it comes with some restrictions because the Ethernet channel implementation on the Catalyst 2960 switch has certain implementation restriction, which includes the interface types cannot be mixed. For example, fast Ethernet and gigabit Ethernet cannot be mixed within a single Ether channel. Currently, each Ether channel can consist of a group up to 8 compatibly configured Ethernet ports. Ether channel provides full duplex bandwidth up to 800 megabit per second or 8 gigabit per second between one switch and another switch or host. The Cisco Catalyst 2906 Layer 2 switch currently supports up to 6 Ether channels. However, as new iOS are developed and platforms change, some cards and platforms may support increased number of ports within an Ether channel link, as well as support an increased number of gigabit Ether channels. The individual Ether channel group's member port configuration must be consistent on both sides. Remember this. If the physical port of one side are configured as trunk, the physical port of the other side must be also configured as trunks within the same native VLAN. Additionally, all ports in each Ether channel links must be configured as layer 2 ports. And lastly, each Ether channel has a logical port channel interface as it is shown here in this figure. A configuration applied to the port channel interface affects all physical interfaces that are assigned to that interface. Ethernet channels can be formed through negotiation using one of two protocols: Port Aggregation Protocol as PAGP or Link Aggregation Protocol as LACP. These protocols allow ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. Let's see each of those protocols. With the Port Aggregation Protocol, pronounced as PAGP, is a Cisco Priority Protocol that aids in the automatic creation of Ether channel links. When an Ethernet channel link is configured using this protocol, packets are sent between Ether channel capable ports to negotiate the forming of a channel. When PAGP identifies matching Ethernet links, it groups the links into one Ether channel. The Ether channel is then added to the spanning tree as a single port. When it is enabled, PAGP also manages the Ether channel. PACP packets are sent every 30 seconds. And PACP checks for the configuration consistency and manages links, addition, and failure between two switches. And it ensures that when the Ether channel is created, all ports have the same type of configuration. PACP helps create the Ether channel links by detecting the configuration of each side and ensuring that links are compatible so that the Ether channel links can be enabled when needed. The modes for PACP are on, and this mode forces the interface to channel without PACP. Interfaces configured in on mode do not exchange PACP packets. We have PACP desirable, and in this mode, PACP places an interface in an active negotiation state in which the interface initiates negotiation with other interfaces by sending PACP packets. And we have even PACP Auto. In this mode, places an interface in a passive negotiation state in which the interface responds to the PACP packet that is received but does not initiate PACP negotiation. The modes must be compatible in each side. If one side is configured to be in auto mode, it is placed in a passive state waiting for the other side to initiate the Ether channel negotiation. If the other side is all set as auto, the negotiation will never start and the Ether channel does not form. If all modes are disabled by using the no command, or if no mode is configured, then the Ether channel is disabled. The on mode manually places the interface in Ether channel without any negotiation. It works only if the other side is also set it on. If the other side is set to negotiate parameters through PACP, no Ether channel will be formed, because the side that is set to on modes does not negotiate. No negotiation between the two switches means that there is no checking to make sure that all the links in Ether channels are terminated on the other side, or that there is a PACP compatibility on the other switch. By considering the two switches in this figure, where the switch 1 and switch 2 establish an Ether channel by using the PACP protocol, depends on the mode setting of each side of the channel. And here in this table, it shows the various combination of PACP modes on switch 1 and switch 2 and the resulting channel established outcome. And now let's go with the other auto negotiation protocol, which was the Link Aggregation Control Protocol, or as LACP, LACP operation. It is part of the switches that allow several physical ports to be bundled to form a single logical channel. It allows switch to negotiate an automatic bundle by sending LSP packets to the other switch. It performs a function similar to PACP, but because LCP is another standard, it can be used to facilitate Ether channels in multi-vendor environments. On Cisco devices, both of these protocols are supported. LACP provides the same negotiation benefits as PACP, but helps create the Ether channel links by detecting the configuration of each side and making sure that they are compatible so that the Ether channel link can be enabled when needed. The modes for this LACP are on, which means that the mode forces the interface to channel without LACP. Interfaces configured in on mode do not exchange those LACP packets. We have the active mode, which places a port in active negotiation state. In this state, the port initiates negotiation with other ports by sending the LACP packets, and then we have the passive mode, which plays support in passive negotiation state, and in this state the port responds to the packet that it receives but does not initiate LACP packet negotiation. Just the same as PAC-P, modes must be compatible on both sides for the EtherChannel links to be formed. The on mode is repeated because it creates the EtherChannel configuration unconditionally without PAC-P or LACP dynamic negotiation. LACP allows for 8 active links and also 8 standby links. A standby link will become active and should one of the current active links will fall. And same as the PAC-P, let's consider this figure where we have switch 1 and switch 2 establishing an ether channel by using the LACP depends on the mode setting on each side of the channel. And based on that, we have the table that shows the various combination of the modes on switch 1 and switch 2 and the resulting channel established outcome. Now that we know about the Ether channel, let's start configuring it. And there are certain guidelines and restrictions that are useful when we configure the Ethernet channel. The Ether channel support, which means that all Ethernet interfaces must support Ether channel with no requirement that interfaces be physically contiguous. We have speed and duplex, which means that configuring all interfaces in Ether channels to operate at the same speed and in the same duplex mode. And about the VLAN match, means that all interfaces in Ether channel bundle must be assigned to the same VLAN or be configured as a trunk, as it is shown here in this figure. And then we have even the range of VLAN, which means that an Ether channel supports the same allowed range of VLANs on all the interfaces in a trunking Ether channel. If the allowed range of VLAN is not the same, the interfaces do not form an Ether channel even when they are set to auto or desirable mode. If the setting must be changed, configure them in port channels interface configuration mode. In any configuration that is applied to the port channel interface also affects individual interfaces. However, configurations that are applied to the individual interface do not affect the port channel interface. Therefore, making configuration changes to an interface that is part of an Ether channel link may cause interface compatibility issues. The port channel can be configured in access mode, trunk mode, or on a routed port. So let's configure one of the AutoNegotiation protocol, which we will send with link aggregation control protocol. And Ethernet channel is disabled by default at the switches and must be configured. And here we will have a topology as it is in this figure to demonstrate an Ether channel configuration by using the LACP protocol. When we need to configure the Ether channel with this protocol, will require 3 steps. At the step 1, we specify the interface that composes the Ether channel group by using the interface range followed by the range of interfaces in global configuration mode command. The range keyword allows you to select several interfaces and configure them all together. The step 2 is creating the port channel interface with the channel group command followed by an identifier and mode active for the interface range configuration mode. The identifier specifies a channel group number. The mode active keyword identifies that this is an LCP Ether channel configuration. And the step 3 is to change layer 2 setting of the port channel interface. We must enter channel interface configuration mode using the interface port channel command followed by the interface identifier that we set in the step 2. And here in this example, switch 1 is configured with LACP Ether channel, and the port channel is configured as a trunk interface with the allowed VLAN specified, as you can see here. So all the interfaces of the Ether channel will be part of a trunk that allow VLAN 1, 2, and 20. And here is an example about the LACP configuration now in the switch 2. And this is a syntax checker. And as you can see, same here, we have to go into interface 0, 1, and then we have to create the channel group. So we will create the group 1 following by the mode, the mode will be active for enable HCP unconditionally. As you can see here, is using the channel group mode active, and then we will go to the create the interface port channel followed by the identifier, and those interfaces will be in the mode trunk and will allow the same VLANs that were assigned in the switch 1. As we mentioned, the both sides will have the same trunk mode and allow the same VLAN. So the channel will be active. As always, after we configure our devices, what we have to do is to verify the configuration. If there are problems, you will also need to be able to troubleshoot and fix them. And here there are some commands to verify, as well as some common Ether channel network problems and their solution. So let's go with the verification commands for the example that we have in the figure. We have the show interface port channel followed by the identifier, and with this command we will display the general status of the port channel interface, and here is for port channel 1, and as we can see it is up. Then we have the show ether channel summary, and when several port channel interfaces are configured on the same device, we use the show ether channel summary command to display one line of information per port channel. And here in this output, the switch has one ether channel configured as group 1, as you can see, and it uses the LACP protocol auto configuration. The interface bundle consists of the fast Ethernet 01 and fast Ethernet 02 interfaces. The group is a layer 2 Ether channel, and it is in use as indicated by the letter SU in next to the port channel number. And then we have either the show ether channel port channel, and with this command we will be able to display information about a specific port channel interface as shown here in this output. In this example, the port channel 1 interface consists of two physical interfaces with fast Ethernet 01 and fast Ethernet 02. And as you can see, it uses the LACP in active mode. It is properly connected to another switch with a compatible configuration, which is why the port channel is said to be in use. And the last command that we can use for verification is the show interface EtherChannel. With this command, we can provide information about the role of the interface in the Ether channel as it is shown here in this output. You can see that the interface path 01 that we are looking for is part of the Ether channel bundle 1, and the protocol that is in use is the protocol LACP. So there are some common issues with the Ether channel configuration, and these issues are as the following, where the assigned ports in the Ether channel are not part of the same VLAN or are not configured as trunks, and the ports with different native VLANs cannot form an Ether channel. And then we have the trunking that was configured on some of the ports that make up the Ethernet channel, but not in all of them. It is not recommended that you configure trunking mode on individual ports that make an Ether channel. When configuring a trunk on an Ether channel, verify the trunking mode on the Ether channel. And then, if the allowed range of VLAN is not the same, the ports do not form an Ether channel even when PAC-P is set to auto or desirable mode. And lastly, the dynamic negotiation option for both auto-negotiation protocols are not compatibly configured on both ends to the Ether channel. And let's see an example about this. We have this figure where the interfaces fast01 and fast02 on switches 1 and 2 are connected with an Ether channel. However, the Ether channel is not operational. So what we will do, step 1, we will view the Ether channel summary information. And the output shows that the Ether channel is down. Then we go to the step 2, where we will find port channel configuration. And as it is shown, we use the command show run, beginning with the interface port channel. And in the output, you can see that there are incompatible PAC-P modes configured on switch 1 and switch 2. As you can see, this is for the switch 1 and this is for the switch number 2. This is mode trunk, and there are the VLANs that are listed in both of them. But as you can see, here is mode desirable and the channel here is mode 1, which means that the modes are not compatible between those two. So we go to the step 3, which is correct the misconfiguration. To correct the issue, the PAC-P mode on the Ether channel is changed to desirable, and the Ethernet channel and spanning tree protocol must interoperate. And for this reason, the order in which channel related commands are entered is important. So what you will do first is that you will say no interface port channel 1, and then you have to create once again interface range path at Ethernet 0, 1, and 2. You will create the channel group and you will set the identifier and the mode as desirable at the switch 1, so it will match with the mode at the switch number 2. And you will say no shutdown, and then you have to go to the interface and make the interface as trunk mode, so it will be compatible with the mode of the switch ports in the switch number 2. And lastly is verify Ethernet channel operational. So once again, we will use the show Ethernet channel summary, And as you can see, now the Ether channel is active and is in use. So that was all about the Ether channels, where we got the information about the Ether channel, what is the function of Ethernet channel, the two protocols, AutoNegotiation, that are used to create the Ether channel, and then we configure those Ethernet channels. And the last step was about the verification of the configuring those protocols. So see you to the next session, and do not forget to subscribe at this channel and share the video with your friends if you like it. See you soon.